Okay, in this concept, we're going to talk about compound interest. And compound interest is yet another extension of exponential growth. Okay, so whereas again, I like to compare to the formula for exponential growth, which was y equals c times 1 minus r to the t, right? You'll notice that this formula, or the formula for compound interest, is very similar to the original formula for exponential growth. I'm sorry, this is 1 plus r for growth and 1 minus r for exponential decay. Okay. The main difference here is that now we have a something called the compounding term, okay, which in this case is n, right? This is the main addition here in the formula for compound interest. And this compounding term essentially tells us how many times the interest rate is calculated per the time period. Okay, so it combines with the time period, right, and the rate to tell us how often the rate is actually calculated. Okay, how often the growth is calculated. Okay, let's look at an example. Sarah invested $4,000 in a certificate of deposit that matures in 5 years. So the total number of years the money is invested is 5 years. The interest rate was 5.25% compounded quarterly. So what does that mean? That means that this interest rate is calculated every quarter. So every time, um, every time a quarter passes, right, which is 3 months. So 4 times a year. Okay, so it's calculated 4 times a year. It's not 5.25% once per year. Okay, so the time unit rather, right, is every quarter, and that's why here in our time, right, we multiply n times t, n being the number of times that the interest is compounded, right? So let's say we have 5 years total, but the money is compounded for the interest um, is compounded 4 times each of those years. So the total compounding periods now are 20, not just 5, right? So this is the main difference between the compound interest formula and the general formula for exponential growth. Let's continue with the example. So what is the balance of the account after 5 years? So again, we rewrite the general equation of compound interest. So A, here we're using, slightly different letters. So A is the final amount of investment, P is the principal, right, the initial amount. And then again, R is the rate, as we know, T is the time, and then N, again, is the number of times that the interest is compounded. So A equals P times 1 plus R over N to the NT power. Plugging in the values, so the principal was 4,000, right? So plugging this in for P, the rate is 5.25%, which is 0.0525 as a decimal, right? So that's my R. Plug it in here. And then n equals 4. Why does n equal 4? Because, well, the interest rate is compounded quarterly. So it's compounded 4 times per year. Okay? So 4 times per year. So my n is 4. Here and here, it's 4. And then t, my time period, is 5 years. So t equals 5. Okay? So plugging all these values in and then evaluating by calculator, we get the final amount as $11,352.79. Okay? So Sarah started by investing $4,000 in 5 years. That became $11,352.79. The power of compound interest. Okay? Here we have an exercise. Please pause the video, work on this, and come back for the solution. Okay, so a bank pays 6.4% annual interest, compounded quarterly, right? So my n is equal to 4 because it's compounded 4 times per year. The interest rate is 6.4%, which is 0.064 as a decimal, right? And then if $5,000 was initially deposited, so the principal is 5,000, right? What is the balance of the account after 8 years? So my T is equal to 8. Okay. So again, I start by writing my formula for compound interest. A equals P times 1 plus R over N to the NT power, which equals, so P is 5,000. So just, just straight up plugging in. 1 plus R, which is 0.064 over N, which is 4. I'm sorry, 4. And then to the 4T, 4 times T is 8. So 4 times 8, right? And then just evaluating this whole thing by calculator, we end up with $8,309.38. Okay. So if somebody invested $5,000 initially in this bank at this rate, compounded quarterly, then 8 years later they would have this much money. Okay, from $5,000 to $8,309.38. Okay, hopefully this was clear. This is it for this concept. See you in the next video.